Good morning, class. So we are looking at the material from yesterday that some of you guys had difficulty with, and this unit is quite difficult, so that is perfectly fine. Thank you for reaching out and letting me know that you are having difficulty with it. Okay, so what we're going to look at here, I'm just going to do one of these examples in the table. We have mass, mole, volume of the solution, and the molar concentration. So we have mass, which is lowercase m, number of moles, which is n, volume of solution, which is V, and then molar concentration, which is C. Now, molar concentration, I'll either write it as moles per liter or molar mass. Let me make this a little bit easier to see. So which formulas do you need to know? Well, everything, like I said, from Unit 3, everything is now moles. I don't want mass anymore. And so for moles, we have to do mass divided by molar mass. From that, then we get to work with concentration, which is concentration equals number of moles divided by volume. Now, here's the weird thing, is that, see this uppercase M? That is the variable for molar mass. Sometimes you'll see uppercase M for concentration. That's the same as moles per liter. Okay, so they're interchangeable. So these are the two formulas that we'll need for the first part of the equation, or sorry, for the handout. This is concentration equation. And whenever you see square brackets, that's what concentration is. That's my short form, okay? Anything in square brackets means it's a concentration in either liquid or in gas. The other formula we'll use is the dilution formula, which is concentration and volume of a first solution is equal to concentration and volume of the second solution. So you need to have 3 out of the 4 values in order to use dilution. And you'll always see the word diluted. Dilution is diluted in the question. And you're saying, well, of course, Ms. Fellow, that's kind of obvious, but it's amazing how many students have difficulty identifying which question is actually a dilution question. All right, so when I'm looking at this over here, which one do I want to do? Which one do I have? Okay, I have all the molar mass of ammonium chloride memorized, so I can do that one. All right, so when I'm looking at this, I have 2 variables that I have to find. I have to find volume, and I have number of moles and concentration, and I have to find mass, and I have number of moles. So you always need 2 out of the 3 variables in order to solve. So for this first one, volume is equal, when I rearrange the equation, is equal to N over C, or number of moles divided by concentration. So if I have 3.40 molar or moles per liter, do you see how it's big M over here? It can also be moles per liter. It's the same exact thing. That's my concentration. And the number of moles is 0.850 moles. And so if you do that on your calculator, 0.85 divided by 3.4, I get 0.25. And then keeping with significant digits, 0.25 liters. Or 250 milliliters. Remember that the conversion is a factor of 1,000. And now for mass. I need to find out what the mass is, which is going to be the number of moles times the molar mass. And you're saying, well, you only have the number of moles. No, I always have molar mass. Molar mass is always a given because I have my periodic table. So ammonium chloride, well, we have ammonia, nitrogen, which is 14.01, plus 4 hydrogen, plus chlorine. And no, you're not expected to know these off by heart ever. It's just when you start doing this too many years, you get to know them. And so now I have a molar mass of 53.50 grams per mole. So I multiply this by 53.50 grams per mole. And again, I need 3 significant digits. So when I round 45.475, 45.8 grams. And those are the two equations that are very important for solution stoichiometry, and you will use them throughout this unit and up until next year. Okay, so the concentration formula as well as the molar mass and mass formula. Now this one, describe how you would make each of the following solutions. This is a procedural question. Part of our curriculum is teaching you how to use the equipment in the lab, and unfortunately for you guys don't get any lab time. But it's very important that when we let students loose in the lab, that you guys kind of have an idea of what you're here to do. And here's the thing is most students don't have any idea of what to do and what equipment to use. And it's all the way into university where my friends who are TAs, they tell me that kids come in and they don't have any idea of what equipment to use. So this is our attempt to say, hey, this is what you should be using. All right, I'm not going to give you detailed paragraph forms, but we're going to look at, okay, if I need 500 milliliters of 0.45 mole per liter magnesium nitrate solution. The first thing I'm going to do is I have to find out how much mass of magnesium nitrate to put into the solution. So before I can even write my procedure for A, I have to figure out how much mass of magnesium nitrate that I need. Well, I'm not given the number of moles, so I have to find the number of moles required from the volume, which is given, times the concentration. And so if you find, okay, so again, volume should always be in liters. So we have half a liter times 0.45 mole per liter. That's going to be 0.225. Oh my goodness, I'm sorry, I'm having iPad issues. It's working offline. Told you guys my internet is terrible up here. Okay, so now I have a number of moles. Now I'm going to find the mass, number of moles times molar mass, and I don't have this one. Let's say it's 123 grams. So I need 123 grams of magnesium nitrate. How am I going to do this? Well, you're going to, let me take a different color. You're going to take a weigh boat. If you don't know what those are, they're the little plastic trays that we would put all the different ionic compounds on. You've definitely worked on them. They're flexible so that you can scoop things in and you can pour them out. Okay, so you're going to take a weigh boat. You're going to put it on an electronic balance. Don't call it a scale, although that is what it's a weighing apparatus that students like to call a scale, but we call it a electronic balance. And you're going to do something, you're going to tare it or you're going to zero it. Both of those words are interchangeable, so that when you put the weigh boat on, you press 0 or you press tare, it doesn't account for the weight of that weigh boat. Then you're going to use a scoopula, my favorite. word in chemistry, I think. A scupula, and you're going to measure out 123 grams. So that's your mass taken care of. What are you going to do with the material? How are you going to make the solution? Well, you're going to put the amount into, okay, do you see how it's a very nice number? It's 500 milliliters, half a liter. Again, if we were in the lab, I'd be able to show you all the equipment. And when we were in the lab, if you were in the lab, we have, don't make fun of my drawing skills, we have these very specialized tools called volumetric flasks. And you would get a 500 milliliter volumetric flask. And then let's pretend magnesium nitrate is rainbow color. You're going to put magnesium nitrate into the volumetric flask that's labeled 500 milliliters. And then, do you see this spot up here? There's an etched line that gives very, very precisely the amount up to 500 milliliters. And so you're going to, once you have the magnesium nitrate into your volumetric flask, you're going to fill the volumetric flask with distilled water to the meniscus. You have a meniscus in your knee. There's also meniscus in, on this volumetric flask. And this is where, if you were to fill with water, if this is the meniscus line, because of cohesion and adhesion in water, you're going to get sticky water to the sides. And you want, oh, let's draw it better. There we go. Do you see how the meniscus and where the water level drops down to this point here? You want that level to be on the meniscus. Okay, so these questions here are, we want you to think about the equipment, think about procedure, also safety. You know, you should be wearing goggles. We don't really make you work with anything too dangerous, but that's what these questions are about. So that, for instance, I can tell you guys, when you go to first year chemistry, and anybody who's taking a science degree, you have to take first year chem. You have to make your own solutions, and you have to know how to do it, and you have to know how to do it properly. And so you have to be able to calculate how much you need, use the electronic balance, put it into the volumetric flask, fill it up with distilled water. There's so much room for error. And so we want to make sure that you guys are well prepared. All right, describe how you could, how you would make each of the following solutions from the given stock solution. So dilution questions, you first are going to start off with doing the calculation. So C1, V1 equals C2, V2. Describe how you would make each of the following dilutions from the given stock solution. So again, see, dilution. That's why I know to use C1, V1 equals C2, V2. You have 18 molar of stock sulfuric acid solution and 500 milliliters of 0.75 molar is needed. All right, so what's my one, C1 or V1? It's this one, okay? You have 18 molar solution. What do you want to make? Let me change this to a, oh, I can't do a, oh, whatever. This is my 2s. This is my V2, and this is my C2. And that's probably turning up very terribly, I'm sorry. So let's calculate first. I have 18 molar. I need to calculate how much sulfuric acid, and you'll notice that in my process work, I don't include units until the very end, or I go back and forth. That's completely fine. Just make sure your final answer, you include the units. My next concentration is 0.750 molar, and the volume, 500 milliliters, right? What did I do wrong? 500 milliliters. I have to change it to liters. So let's do this quickly on our calculator. 0.5 times 0.75 divided by 18. And I get this number, 0.0208, kind of an ugly number. So I'm going to use 20.8 milliliters. Now, your procedure for a dilution is you're going to either use a pipette or a graduated cylinder. For 20.8 milliliters, I'd probably use a graduated cylinder. You might have to use two. You might have to use one that you would calculate 20 milliliters and one that you would calculate 0.8 milliliters, or you can use a pipette. Again, you'd probably have to use two pipettes, one that got you the 20 milliliters and one that got you the 0.8 milliliters. And then what are you going to do? Well, you need 500 milliliters, so you're going to get a 500 milliliter volumetric flask. And what you're going to do is, there's a rule in chemistry that it's acid first and then water. Oh wait, no, I have it backwards. That's awful. Water first and then acid. So you're first going to add, how embarrassing. First, you're going to add a little bit of water, and then you're going to put in the sulfuric acid. Why? Because if you have the sulfuric acid, say you put 20.8 milliliters of sulfuric acid, and then you put in some water, and say by accident you dropped it, by accident you poured it onto yourself, whatever. If you have all the concentrated sulfuric acid with a little bit of water poured onto you, I hope you guys can't hear that noise. If you have it all poured onto you, you're going to get a burn. You're going to get a chemical burn, and they're pretty nasty. But if you put some water in first and then you put in the sulfuric acid, you've diluted it right there in that step. And so if you spill it, you're spilling diluted sulfuric acid rather than the concentrated sulfuric acid. And you're also worried about, say, if you're doing it in a beaker and not a volumetric flask, you're worried about splashback as well. So if you drop acid into water and it splashes, it's going to be diluted acid because it's already mixed with water. But if you drop water into the acid, then it's only been diluted a little bit, and that splashback could cause some serious burns. And so that's why, again, we make you wear goggles. All right, and then you're going to fill it up with distilled water to the meniscus line. Okay, now onto these questions. These now we don't have to explain, and we asked you to do number 1 and 2, so I'm not going to do that for you. I'm going to do number 5. Many solutions are prepared in the laboratory from purchased concentrated solutions. What volume of concentrated 17.8 mole per liter stock solution of sulfuric acid would laboratory technicians need to make 2 liters of 0.20 mole per liter solution by dilution of the original concentrated solution? That was a mouthful. All right. C1, V1. C2, V2. I can read these questions and I know exactly what I'm doing. Take a second now, fill in C1, B1, C2, B2. Pause the video or whatever. Did you fill it in? I hope so. Okay, so what volume of concentrated 17.8 mole per liter stock solution? That is C1. That's what I'm originally starting with. Would a laboratory technician need to make 2 liters? Need to make. So they're doing something to it. So it's B2 of 0.20 mole per liter solution by dilution. Okay, also dilution, that's what gave it away. That was C1, B1 equals C2, B2. So what am I solving for? V1. Now you can rearrange your equation. C1, V1 equals C2, V2. Okay, all those years of algebra are paying off in chemistry because we need you to be really good at rearranging equations. Or you can do what I do and I just plug in everything to the equation, and then once I have the numbers in, then I rearrange it. So I go 17.8 times V1 equals C2. Oh, no, plug in my numbers. See, I don't have you guys in front of me saying, Miss Fella, you did it wrong. I actually really appreciate it. Okay, so there we go. So what am I going to do now? I have to move over the 17.8, 0.200 times 2.00 divided by 17.8, and 0.2 times 2 divided by 17.8. I need 3 numbers of significance. I get 0.0225 liters. Or how many milliliters? 22.5 milliliters. So therefore, 22.5 milliliters of 17.8 mole per liter sulfuric acid is required. All right. Have a try the other questions and let me know if there's anything else I can help you with. And I hope you're doing well. Miss you guys.